And we take a look in this video at some more aspects of trigonometry. Specifically, we're going to take a look at radian measure, what it is, why and how we use it, and if time permits, and it should, we're going to take a look at some trig graphs, specifically the sine graph and the cosine graph. Things that should help you in the last couple of years of high school. Great! So let's talk about radian measure. In radian measure, the big thing for you to remember is that pi radians is equivalent to 180 degrees. And that is because on the unit circle, a circle of radius 1, to go 180 degrees around that circle, halfway around that circle, covers a distance of pi. The unit circle is something that keeps popping up in trigonometry. The unit circle is in play here. Pi radians is equivalent to 180 degrees. So we look at everything through that lens. So when we want to talk about 45 degrees, well, 45 degrees is a quarter of that, and so that's pi over 4. And then all your multiples of 45 degrees are multiples of pi over 4. Similarly, 30 degrees, well, 30 is 1/6 of 180, so 30 degrees is pi over 6 radians. And so every multiple of 30 degrees is a multiple of pi over 6. 150 degrees would be 5 pi over 6, and so on. So why do I care about radian measure? Well, there are a couple of formulas that you're supposed to know how they work. One is the formula for arc length, and one is the formula for area of a sector. And let's be clear about what we mean by this. So I have some circle, and there is a central angle in that circle of measure theta. Central angle, vertex at the center of the circle. The circle has a radius of r. This arc length is L, and there's some area inside that sector. The formulas for arc length and area of a sector are that the arc length is theta times r, and the area of a sector is 1/2 times theta times r squared, but only if theta is in radians. So r is the radius, and theta is the angle measure in radians. So if you have some circle with a nice central angle, and that central angle is 62 degrees, and the radius of the circle is 10 centimeters, I want the arc length, and I want the area of the sector, and both of those are fairly straightforward to figure out. The arc length would be theta times r. R is easy to find. Theta, not so much. We've got to convert 62 degrees into radian measure, because I can't write 62 there, because 62 is not a radian measure. So I've got to convert that to radian measure, and we convert from degrees to radians by multiplying by pi over 180. And so then when we simplify, this is 62 pi over 18, which I imagine simplifies further. Now, we could get a decimal equivalent of that to 3 significant figures if we chose, but 31 pi over 9 is 8, and it is an exact answer. The area will go similarly, 1/2 times theta times r squared. And so I have no idea what that simplifies to. The 10 cancels out with the 18. So you've got 620 pi over 36. And I imagine that this reduces down to some other number, which is irrelevant, except that it's equivalent to 620 pi divided by 36. You can find your arc length. You can find your area of a circle. It's not too bad. The other kind of problem that pops up in this regard is you've got some central angle. It's theta. You've got some radius r, and we'll pretend that the intercepted arc has a length of 8 pi, and the sector, oh, I should make sure I get this right. Let's do it this way. Let's let this be 10 pi, and let's let the area be 28 pi. And we'll try to find a theta and an r. Well, each of these pieces of information give us different equations. The arc length is theta times r. The area is 1/2 times theta times r squared. So the question is, how do I put those pieces of information together to get myself the value of r? So hit the pause button, think about it. No, really, hit the pause button and think about it. Okay, fine. So let's look at the blue equation. The blue equation tells me 28 pi is 1/2 times theta times r times r, right? So what do I do with that? Well, this is theta times r, and I know a little something about theta times r. So now I know that 28 pi is 1/2 of 10 pi times r. Oh. And once I know that, r is pretty straightforward. That's not too bad. That's not too bad. And once I know what r is, substituting to get theta is a piece of cake. 10 pi is theta times r, so theta is 50 pi over 28, and I'm sure that that reduces. Not too bad. Not too bad. There are some things you should know how to do based on all of this. So let's pretend that I have a central angle. That central angle is 120 degrees, and I have an area of 30 pi square meters. I want to find arc length. That's one thing to consider. The other thing to consider is I have some circle with some central angle, theta, and some radius r, and the arc length is 6 pi, and the area is 12 pi. I'm interested in theta and r. That is something you should now be able to do based on what you have just seen. The other thing we do with radian measure is we find ridiculous things like the sine of 5 pi over 4. We find ridiculous things like the sine of 5 pi over 4. So how exactly do we find the sine of 5 pi over 4? Well, pi over 4, that's a 45-degree angle. So if I'm trying to get to 5 pi over 4, that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. This is 5 pi over 4. So it's awfully hard for us to think in terms of right triangle trig with an angle like 5 pi over 4 because you can't fit an angle like 5 pi over 4 in a right triangle. But you can create a right triangle by dropping a perpendicular to the x-axis, and that's how we do it. And we say that the sine of 5 pi over 4 is the same as the sine of this reference angle, right there. So it's time to play everybody's favorite game, how big is it? How big is that reference angle? Well, this is pi, so if I have 5 pi over 4 minus pi, let's see, that's 5 pi over 4 minus 4 pi over 4, that's 1 pi over 4. This reference angle is pi over 4. And so I ask myself, what is the ratio of the sides of a pi over 4, pi over 4, pi over 2 right triangle? This is the standard 45, 45, 90 right triangle. And the sides are 1 and 1 and the square root of 2. They are some multiple of 1, 1, square root 2. So what do we do with that? Oh, we need some space. What do we do with that? We remember that this one comes out in a negative direction, and this one comes out in a negative direction. Hypotenuses are positive by definition. So when I go to find the sine of 5 pi over 4, that's the sine of the reference angle. The sine of the reference angle is opposite over hypotenuse. And I'm done. Similarly, we could find the cosine of 11 pi over 6. The cosine of 11 pi over 6. Well, all the way around would be 2 pi, that's 12 pi over 6. So 11 pi over 6 is almost that far. And in fact, this reference angle is in fact pi over 6. Drop a perpendicular, got ourselves a right triangle. What kind of right triangle do we have? We have the 30, 60, 90 right triangle. The sides of the 30, 60, 90 right triangle are in the ratio 1 to 2 to square root of 3. 2 is the biggest. 2 is bigger than the square root of 3. And so that goes on the hypotenuse. 1 is the smallest of those three sides. 1 is smaller than the square root of 3. That goes on the opposite side, and then you've got square root of 3 sitting right here. This square root 3 comes out in a positive direction. This 1 comes out in a negative direction, and hypotenuses are positive by definition. So we say that the cosine of 11 pi over 6 is the same as the cosine of this reference angle. And the cosine of this reference angle is adjacent over hypotenuse. Hopefully this is something you have seen before. And hopefully you have enough skill at this point to be able to find the tangent of 5 pi over 3 and the cosine of 3 pi over 4. Those are things you should know how to do. We've got a little bit of time left, and in that little bit of time, I want to talk ever so briefly about the sine graph and the cosine graph. The sine graph and the cosine graph. The key quadrantal angles from 0 to 2 pi look like so. And we'll go like that. The sine graph hits 0 every pi. And the sine graph is an alternation of hills and valleys. And if we were to continue the graph, it's more, oh, whoa, how about that? If we were to continue the graph, it's another hill and a valley and a hill and a valley. It's a valley and a hill going left. That is the sine graph. The cosine graph looks just like it, except it starts high and ends high and hits bottom somewhere in the middle. So we end up with the same graph, but shifted to the left, or if you like, to the right. That's the cosine graph. Some things you should know about these graphs. The amplitude of each graph is 1. The amplitude is the vertical distance between the max and the midline. The midline is the line that runs right through the middle of the trig graph. That's the amplitude. The period of each of these graphs is 2 pi, because after 2 pi has passed horizontally, we have finished one cycle. Period talks about how long it takes to go through one cycle. So, what happens when you try to graph y equals 3 sine 2x? Well, this 3 is the amplitude. And so we would need a graph that looks just like this, but which was stretched vertically 3 times as big. Stretched vertically 3 times as big. And then this 2 is called the frequency, and it implies that the period is 2 pi over that frequency. That graph repeats its cycle every pi. So if I were to graph 3 sine of 2x, I would have a graph that has an amplitude of 3 and a period of pi. So it would go up to 3, down to -3, and every pi, you get a brand new cycle. Does that sort of make sense? Almost, kinda, sort of, kind of, almost, not really, a little bit? Okay, that's the kind of thing that we're supposed to remember. The question pops up on exams in 2 forms. One is where you're given an equation and told to come up with a graph. The other is where you're given a graph and you're told to come up with an equation. And so let's pretend that this is 210 and this is 8, 2, and the equation of the graph is of the form y equals a cosine of b times x minus c plus d. These questions are easy to know how to do if you work systematically. If you were to work systematically, you would recognize that this is where the midline runs through. This is the vertical shift from our study on functions. It's the vertical shift. Where is that vertical shift going to be? It's going to be midway between those y values. 10 plus 2 over 2, that's 6. D is 6. The amplitude, that's A. Actually, A is the absolute value of the amplitude. The amplitude is the vertical distance between the max and the midline. So this is 10 minus 6, that's 4. And so then we have to ask ourselves what C is. C is the horizontal shift, sometimes referred to in trig circles as the phase shift. Well, the horizontal shift, normally a cosine curve will start a cycle at x equals 0, but here we start a cycle at 2, so C must be 2. And then as for B, B is the frequency. B is 2 pi divided by the period. So the question is, how long is the period? Here the period, half a period runs from 2 to 8, that's 6. So a full period would be 12. So when I go to write my equation, the amplitude is 4. B we said was 2 pi divided by 12. C we said was 2. And D we said was 6. And so we can come up with that equation just by knowing here's where the midline is. The midline drives the amplitude. Horizontal shift we can look at independently. And then we know B because we know period. This question is going to pop up at some point in your last 2 years of high school. I want you to get it right. I think you can do it. All right, that's enough. We'll see you soon. Thanks for watching.